Hello everyone, so today I'll present my Physics 1 final project, which is the physics of movies. For this project, the scene that I choose is a scene from Haikyuu. It's the scene where Hinata smashed the ball, and yes, this scene is scientifically possible to be done. The scene is when Karasuno is competing against Fukurodani in the training camp. The scene is where the renowned Kageyama Hinata minus Tempo Quick takes birth. The physics law and concept applied in this scene and project is first, Newton's second law, which is about acceleration. Next is force, which are constantly used in serving and spiking the ball. Then there is momentum. Every time the ball is struck with a force during a game or practice, there is a resulting impulse and momentum. A greater force on the ball will have a greater impulse and therefore a greater momentum. So the players must learn to control their force to keep the ball in bounds. Next is impulse. A volleyball player jumping up and spiking the ball in the air is the good example of impulse. And the last one is potential energy, which is the energy applied when hitting the ball. The hypothesis for this project is if Hinata is fast enough, then he will be able to smash the ball to Fukurodani's. Here is the FBD or free body diagram that I made. There is Hinata, which is the first object. Then there is Kageyama as the second object, and the volleyball as the third object. While the force and acceleration is going towards from Hinata to the ball. Here are the given measurements. First is Hinata's mass, which is 52 kilograms. Then Kageyama's mass, which is 66 kilogram. Hinata's height, which is 1.64 meter. Kageyama's height, which is 1.81 meter. The mass of the ball, which is 0.28 kilogram. And lastly, the gravity, which is 9.8 meter per second square. The first topic to be explained is acceleration. A player can also create topspin on the ball to make the ball accelerate towards the ground. And it is known that Hinata's acceleration is 110 meter per hour. With that, we can identify the force that he puts into the ball. We need to find the mass and the acceleration, and we have both. The mass is 0.28 kilograms, and the acceleration is 110 meter per hour. Therefore, to find the force, we need to multiply the mass and the acceleration, which is 0.28 multiplied by 110, and it gives us 30.8 Newton. So the force that Hinata applied to the ball is 30.8 Newton. Next one is energy or potential energy. Uh, we will find Hinata's potential energy first. To find the potential energy, we need the mass, the gravity, and the height, and we have all of them already. So we need to multiply all of them. So Hinata's mass is 52, multiplied by the gravity is 9.8, and multiplied by its height is 1.64. And it gives us 835 and 744 joules. That is Hinata's potential energy. Next, we need to find Kageyama's potential energy because he is the one who gives the ball to Hinata. Same as before, we need to multiply the mass, the gravity, and the height, which gives us 66 as Kageyama's height, mass, multiplied by 9.8 as the gravity, and multiplied by 1.81 as Kageyama's height, which gives us 1,170 and 708 joules. That is Kageyama's potential energy. Next one is the impulse. For the impulse, we need to find the force and time. We have found the force before, which is 30.8 Newton. In the time, the average of Hinata is 1.2 seconds. So 30.8 Newton multiplied by 1.2 seconds is equals to 36.69 J. The last concept applied here is momentum. Uh, we need the mass and the velocity. So first we're using Hinata's mass, which is 52 kilograms, and Hinata's velocity, which is 9.410 meter per second. We need to multiply the mass and the velocity. So 52 as the mass times 9.410 as the velocity is equals to 489 and 32 kilogram meter per second. And that is Hinata's momentum. So, is my hypothesis true? Yes, my hypothesis is proven to be true. And here are some conclusions that could be taken. Kageyama's potential energy is bigger than Hinata's since he is heavier and taller. Also, Hinata's fast speed produces a high acceleration and velocity, which makes the force and the momentum bigger. The bigger the force and the momentum makes the ball get smashed into Fukurodani's side. So yes, it is true that Hinata is fast enough to smash the ball to Fukurodani's side. Thank you.